Hello, Assalamu alaikum. Good morning. Today we are going to discuss about deflection amplification factor, often denoted as CD. Is a parameter used in seismic design codes to estimate the actual expected displacements of a structure, actual deflections of a structure during an earthquake based on the elastic analysis results. Okay, let us first discuss how this is different from how the elastic and inelastic behavior differed between each other. Let us consider a major earthquake. During that, structures undergo inelastic deformation rather than remaining purely elastic. And also amplification. So this is a factor actually which accounts for the fact that actual displacements in a yielding structure are larger than those predicted by elastic analysis. And what is the code requirement? So it is required parameter in seismic design codes like ASC, ASCE, and international building codes and similar codes such as Indian code, British code. And the relationship mathematical representation of this factor, you can generally delta max, it is equal to CD times delta E. So here what we are doing is the maximum inelastic displacement, we are getting it by multiplying the elastic displacement from the analysis with the deflection amplification factor. Okay, now typical values and ranges for these CD values, as I can you can see on the screen. Like for moment frames, it's 5 to 6.5. Braced frames, it is 3 to 5. Shear walls, it is 4 to 5. Dual systems, it is 5 to 6. Cantilever columns, it is 2.5 to 4. And when we see the relationship with other seismic factors, uh, it is closely related with two important parameters such as response modification factor and system over strength factor. Like a response modification factor, it is we can even say that force reduction factor, which accounts for energy dissipation through inelastic behavior. Typically, CD you can say it is almost near equal to R or slightly less. System over strength factor accounts this accounts for reserve strength beyond design and used for element design. And for practical applications, you can say that drift calculations, you have p delta effects, and and so system over strength factor, also the other factor which is related directly with this CD value, which accounts for reserve strength beyond design used for element design. Okay, now when we go for the practical applications where we used this factor is one is calculating the drift calculations, when we want to find the drift value, delta is equal to CD into delta elastic. And also it is used for finding interstory drift ratio. And the other aspect where we use this value is p delta effects, where amplified displacements affect second order p delta effects, and also it must be considered in stability calculations. And for non-structural components, like it is used to determine required clearances, affects the design of partitions, cladding, and equipment. Okay, now let us discuss about the code provisions. ASC 7 example, where these key requirements, minimum values, they are specified in tables based on structural system application. It is applied to elastic displacements from design level earthquakes. Limits combined with other factors for final displacement calculations. Now let us have one calculation. Let us, if a structure has elastic displacement delta E is equal to 1.5 and CD is equal to 5, where then your delta max shall be 5 into 1.5, 7.5 inches. Okay. Now, important considerations which we need to discuss about this factor is like for steel structures, for concrete structures, and for masonry and wood structures. For steel structures, generally higher CD values due to ductility, and concrete structures, these values are lower depending on detailing. Like when you are doing ductile detailing, like in zone D, zones C and D, especially for seismic conditions. So this value will be generally higher. It depends on the detailing actually. Okay. And for masonry and for wood, you have these values shall be depend on the construction type which you follow. Now, coming to the design philosophy, then what are the factors to be taken care? One is the life safety and damage control and serviceability. Okay, so life safety, it is generally our goal will be to prevent collapse, and in damage control, this CD helps estimate repairable damage levels. Yani you can decide the damage levels at which you want to design your structure. And for the serviceability, so it ensures functionality after moderate earthquakes. It is anyway related directly with the damage levels which you allow in the building. And for the limitations and assumptions, you can assume adequate ductility and detailing. Okay, you have to assume here before deciding that. And based on the simplified models, may not capture all nonlinear effects. So nonlinear effects when it comes, so this factor won't give, you cannot exactly figure out this factor. Okay. So in summary, the deflection amplification factor is a crucial bridge between the elastic analysis results and the expected real world structural behavior during earthquakes. Okay, so where it accounts for inelastic deformation that occurs during design level earthquakes, and also it ensures realistic displacement estimates for drift checks and pre-delta effects, and it varies by structural system, like based on whether it is RCC or steel or wood or masonry. Okay, that's all for regarding this factor. Thank you. This factor, deflection amplification factor.